All right, guys, we are going to take a look today at the analyzing solubility graphs. These are notes, so they're guided notes. Make sure that you've got the same paper and you're following along and filling in as we go. So the following graph that we're going to be analyzing shows how the temperature of a solution, and we can see that on the x-axis here, the temperature, in this case in degrees Celsius, of a solution affects the number of grams of solid that can dissolve in 100 milliliters or 100 grams of water. So we can see this, that we're looking at the solubility, so how much will dissolve in grams in 100 milliliters of water. Okay, so the y-axis is very specific. It's showing how many grams of solid we can dissolve in a specific amount of water. So we can see generally that the solubility of this solid will increase with increasing temperature. So as our temperature goes up, our solubility, or the amount of grams that will dissolve, is also going to go up. And this is of potassium nitrate, KNO3. Every chemical would have its own graph, its own line on the graph. We can see a more complex one with multiple chemicals down here on the bottom. It's going the opposite way, and we'll see why in a second. So when we look at a particular temperature, we can see that as we increase the number of grams of solid, the solution will start as a blank solution when it reaches the line. Okay, so when we look at a particular temperature, so if we pick a temperature, say I pick 80 degrees Celsius, as we start to increase that number of grams of solid in the solution will start as an unsaturated solution. When it reaches the line, it becomes a saturated solution. There we go. Okay, so we can, if we start at a particular temperature, we're going to increase our number of grams, and it's going to be unsaturated, 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 till we hit the line, then we're saturated. That line represents a perfectly saturated solution. All the solid will be dissolved. Okay, so everything will dissolve, but you can't dissolve anymore. If we were to continue up on the graph, the solution is still saturated, but you will see undissolved solids appear in the solution. Okay, so underneath, when it's unsaturated, everything dissolves. So everything, all the solid will disappear. We can stir it up and it'll disappear till we hit the line. That's when it's saturated. It will all disappear. But if we add any more and go over that line, we're going to be saturated and we're going to have solids that hang out in the bottom. So when we're above the line, we're going to see some of those solids in the bottom like we saw in our simulation. Okay. And then if we went horizontally on the graph, we could also kind of see what's going on. If we picked a temperature, we could say, okay, at 150 degrees, this solution, KNO3, when we're at 0 degrees Celsius, at 150 grams, that would be saturated. We'd have solids at the bottom, it's continue being saturated. When we hit the line, that's going to be where it all dissolves, but it's saturated. And then if we go past that, we increase that temperature even more, then we're going to be unsaturated. Okay. So by increasing that temperature, we can change that solution. So using the graph, we can determine the amount of solid that will dissolve at a particular temperature. For example, how many grams of KNO3 will dissolve at 20 degrees Celsius? So if we wanted to solve this, we would go to 20 degrees Celsius on our graph, and then I would follow that up to my line, okay, because we want to know how many grams of it will dissolve, the maximum amount. And then I'm going to carefully go over, you can always use a ruler to do something like this, and do my rise run lines. And then we're going to read that point on the y-axis. Now, we're doing our best estimation. It's over half, so it's more than 25. I would say that that's probably close to probably between 35 and 40. Let's say about 38 grams. Okay. Would be how much would dissolve. Now, if you estimate a little bit differently, that's okay. That's my best estimate. So it says we can also find out the temperature of a solution when a certain amount of solid dissolves. Example, at what temperature will 200 grams, sorry, my pen working, will 200 grams of KNO3 form a perfectly saturated solution? Okay, so we want to find 200 grams. Okay, grams is going to be on our y-axis. We're going to follow that over to our line, and we're going to drop a line straight down. That looks right in between 80 and 100, so that's going to be 90 degrees Celsius. Sorry, this green color is a little light. Okay, so again, we can do our rise run lines to help us figure out where those points are and where they connect. Okay, so our line shows us our perfect solubility, and we're using that to answer these questions. Now, it says last thing to note about these graphs is that if a chemical is shown to decrease in solubility, so we're decreasing in solubility, our graphs are going down, our lines are going down, as temperature increases, it is because it is a gas. We can see that in the graph to the right. All of these are gases, and as their temperature increases, less of them will be dissolved in the water. Okay, so you've probably experienced this actually. A great example of gases being dissolved would be in a soda. So if you have a nice cold soda and you open that top, you're going to start releasing the gas out of the soda. So it's going to start releasing that. As that gas comes out, it's becoming less soluble, right? It's coming out of the solution. Now, if we had a higher temperature soda, then more of it would bubble and it would go flat pretty quick, right? So that's one reason why we want to keep our sodas cold, is to keep the gas dissolved in our solution so we get that nice bubbly texture. So let's just try a few of these out. These are going to be using the graph at the top, so we're going to keep using that one. So how many grams of KNO3 will dissolve at 50 degrees Celsius? So we're going to find our given amount, 50 degrees. That's halfway between 40 and 60. We're going to follow that up to our curve, and then we're going to go over straight to our y-axis, and I would say that that's about 90 grams. All right, letter B, at what temperature, so we're looking for a temperature, will 150 grams of KNO3 form a perfectly saturated solution? So we're going to go to 150 grams. We're going to follow that line over till we hit the curve, and then again, drop a line straight down. It's over half. I'd say this one's closer to 75, and we're looking at what temperature, so that's in degrees Celsius. Okay, letter C is a little different. It says, what will you see when 150 grams of KNO3 is added to 100 milliliters of water at 20 degrees Celsius? So we're looking at 150 grams and 20 degrees Celsius. So we're looking at this point here. Okay, what would we see? Well, that's going to be above the line. It's going to be saturated. So we will see a saturated solution, and it will have solid at the bottom, solid undissolved. Right, because we're above that line. If we were right on that line, then it would all dissolve perfectly. All right, similar question. What will you see when 150 grams of KNO3 is added to 100 milliliters of water at 80 degrees Celsius? So now we're looking at 150 and 80. We're looking over here. So now we're under the line. Well, that's the unsaturated part. So an unsaturated solution, all solid is dissolved. Okay. All right, let's check out one more. So if a solution of 225 grams of KNO3 which has white crystals, is dissolved in 100 milliliters of water at 80 degrees Celsius. Would that result in a saturated or unsaturated solution? Explain and describe what you would see in the container. So we're looking at 225 grams in that 100 milliliters of water. Remember, that's already taken care of in that axis. So 225, we're looking between these two, and 80 degrees Celsius. So we follow this over to our 80-degree point. We're looking right there on our graph. So describe what we would see. So we should see a saturated solution. And again, since it's above the line, it will have solid, undissolved at the bottom. All right. So that's how we're going to approach this. You've got a couple of pages of practice using some graphs. So be careful when you read those graphs. Make sure you're using the correct line for the correct chemical and thinking about what it means above, below, and on the line. And then answer the questions that go with it. All right, guys? You can always use these rise run lines to help you connect those points as well. Okay, be careful and make sure you're using some straight lines to figure this out so your amounts aren't off. Okay? All right, thanks.